The last problem that I work from 5.11 problem set is your number 13. In the video, again, the numbering's off. So in the video, it's problem number 38, which is your problem number 13. I don't work it in its entirety, and this is a pretty nasty problem, just FYI. It's still a good one to look at. So make sure you follow along with that, and then know that I don't fully answer it. So I leave it up to you to finish out the rest of the questions. It's just a good starting place.
This is a challenging question. This is actually one of the more challenging questions on this problem set. Okay, so I wanted to go through it with you because it is something that I see sometimes on the AP test, questions like this. So I want to make sure we're good. Okay, let's wrap our heads around this problem. Let f of x equal 6 minus x squared. For w between 0 and square root of 6, let a of w be the area of the triangle formed by the coordinate axes and the line tangent to the graph of f at a point on that parabola. Let's look at this diagram to understand what we're talking about. I'm going to use some color. This is our parabola. Y'all agree that I'm outlining in red in that first quadrant. So this graph in red, that's f of x equals 6 minus x squared. What I'm interested in is if I take a point on that graph, just in that first quadrant, so between 0 and square root of 6, which is where it's going to intersect that x-axis, and I find the tangent line at that given point, some point w. I want to know what this area of this blue triangle is that's created by that tangent line and those axes. So we have this right triangle happening. Okay, do you see, as I move that point along that little curve, that's going to create different triangles, right? Everybody see that? So I want to maximize the area of that blue triangle. This is a complicated question. So first of all, this is a right triangle. So what's the basic formula for the area of a triangle? 1/2 base times height, right? Okay, so let's look at this triangle. So this is my base, and this is my height of my triangle. But I need to put this all in terms of W, right? It says A of W, where W is some point on this curve between 0 and root 6. So I need to come up with this in terms of W. Okay, do you see how my base down here, I need to figure out what this point is right here, yes? Is that the square root of 6? No, square root of 6 is when this curve hits, that's here. Y'all see that? Okay. And then to find the height, I need to figure out what this point is up here. Yes? Okay. Those 2 points, that comes off my tangent line, right? That blue line is my tangent line. So down here, this is the x-intercept of the tangent line. Up here is the y-intercept of the tangent line. Do y'all agree with those 2 statements? The x-intercept and the y-intercept of the tangent line. So what do I probably need to find? An equation of the tangent line, right? Okay, so to find the equation of a tangent line, we need to find a point and we need to find the slope. Well, guess what? This is my point. It's a generic point, right? Because we don't know exactly what point is going to maximize area. So we call our generic point W, 6 minus W squared is on that red graph. Everybody agree that's the point? So now I need to find the slope at that point. So how do I find the slope of the tangent line?
Take the derivative of f of x.
Take the derivative of f of x. So f of x is 6 minus x squared. So the derivative of that is negative 2x. And I want it specifically at my point. So the point we're calling it is f of w. So does everybody agree that negative 2w at the point w is my slope? Are we all good with that? Okay. So now to write the equation of the tangent line. We get y minus my y value of the point? What is the y value of my point?
6 minus w squared.
6 minus w squared. Is what I'm writing down right now, is that correct? No, because it must have parentheses around it. Either put parentheses around it or go ahead and distribute and say minus 6 plus w squared. So I have y minus my y value equals my slope, which was negative 2w, times x minus my x value of w. Everybody good so far? That's the equation of the tangent line. This is a huge problem, right? Because what am I trying to do? I'm trying to find the area of that blue triangle. And the area of that blue triangle, I need to find the x-intercept of the tangent line and the y-intercept of the tangent line. Okay. So how do I find, let's say, the y-intercept of tangent line? What do I do?
Set x equal to 0.
Set x equal to 0. So if x is equal to 0, we get y minus 6 plus w squared equals negative 2w times negative w. Y'all good with that? So we get y equals, that's going to be 2w squared, then minus w squared plus 6, or y equals w squared plus 6. I'm going to pause right there. Everybody good with that being the y-intercept? W squared plus 6. Okay. So now back on my diagram, that's the y-intercept of the tangent line. So what that really is representing is the height of my triangle. That's w squared plus 6. Yeah? So now we need to do the same thing. We're going to find the x-intercept of my tangent line. This is a great problem, right? Talk about problem solving. Good gracious. Okay, let's find the x-intercept of tangent line. Or when y equals 0. So now if y equals 0, we get, what do we get? Negative 6 plus w squared equals negative 2w times x minus w. How do I solve for x here? Somebody tell me what I would do next to solve for x.
Move the divide by 2w and then add the w.
Yeah, you could divide by negative 2w and then add w. You could do it that way. Now that's kind of nasty, so I would, this whole problem's kind of nasty, but I would get a common denominator of negative 2w, so I'd multiply this by negative 2w. So negative 2w squared. So you get negative 6 minus w squared over negative 2w. And I would make this even simpler. Can I just factor out a negative since they all have a negative? So I'd make this w squared plus 6 over 2w. This is what I like to call the problem on the AP test that is made for the super geniuses who have a lot of time and have finished the test and they have time to work through this. Because this is crazy. This is a lot. Most problems on the AP test are not this crazy. All right. So hopefully you rest easy that like most problems are not like this. I know I'm going kind of fast, but any questions so far? Everybody's having fun with this problem, right? Okay, so now I've got the x-intercept of the tangent. Okay, so that's representing that statement down there. That's representing the base of my triangle. So that is this guy, w squared plus 6 over 2w. Okay, we're finally now to the point where we can say, okay, if I want to minimize my area in terms of w, now I have my base in terms of w, my height in terms of w. So now I'm going to make my formula for my area. 1/2 base times height. So I'm going to do that. So my area is equal to 1/2. My base is that x-intercept times my height. The way that I would simplify that, you see you have w squared plus 6 times itself in the numerator. I would write it like that, divided by 4w in the denominator. Now, if that wasn't already hard enough just to get the formula for area, what's the next step now to find the minimum area?
Take the derivative.
Yep, take the derivative, which is going to involve what rule?
Quotient.
Quotient rule. Yeah, so you would take the derivative using quotient rule. You would then set that derivative equal to 0 and solve. It's a massive problem, okay? I'm actually going to stop there, okay? Because I think you understand what to do next, right? Take the derivative using quotient rule, set it equal to 0, and solve, okay? But I just wanted to show you guys this type of question. The AP test likes this like area under the curve problem, like the triangle made out of the curve. This one is probably the hardest I've ever seen of this type of question because there's just so much going in on it.